Just like in our last video where we spent some time thinking about the domain of a function combination, in that video we looked at division, we're going to do the same thing here, but this time we're going to focus specifically on how do we think about the domain of a composite function. So the composite that we're going to try to build is the composite f of g of x. So in order to do this, we have to first define what f and g are. So our f and g are going to be f of x is going to be 2 over x minus 1, and g of x is going to be 3 over x. And we're going to build the composite of these two functions, but more specifically, we're going to focus on thinking about the domain of this function. What does it look like when we combine the two of these together? So, first consideration for the domain is anything in the domain absolutely has to exist in the domain of the inner function. You have to get through the inner function in order to get to the outer function. So we have to first give consideration to the domain of g of x. So seeing that g of x is equal to 3 over x, I think it's pretty obvious to see that there is a single number that would be eliminated from the domain of the function, and that is the number 0. We are not going to be able to use 0 as the input of g, and then by extension, we're not going to be able to use it as in the domain of the composition. The second consideration is what happens after you do the substitution of the function. So we can put g into f, assuming that it's not 0, assuming that x is not 0, and from there determine, are there any other numbers that are going to, is there any other numbers in the real numbers that are going to make this function not work? So let's build our composition and see what happens. So inside of f, wherever we see an x in f, we're going to place g. Similarly to the concerns of the last function that we looked at, g, we're going to focus our attention on this denominator. Just like with g, that denominator is not going to be not able to equal 0. If it did, the whole function wouldn't exist and we wouldn't even have the composition. Looking very quickly at this denominator and thinking about it set equal to 0, we realize that the only number that would make this a true statement is if we made x equal to 3. That would leave us with 3 divided by 3, which is 1, 1 minus 1, which is 0. So 3 is also not allowed. That doesn't mean 3 is not allowed in G. 3 definitely works in G, but it fails when we build the composition. It's able to produce an output in G, but it is not able to produce an output in f of g. And that's the extra consideration that we need. So our domain, we can build in interval notation. We're good all the way up to 0. We're good between 0 and 3. And we're good after 3. We have opens. We're careful to write our opens on each of these, as we cannot be 0 and we cannot be 3.